In this video, I will consider one numerical on maximum power transfer theorem. Determine the value of RL when maximum power is transformed across it. Also find the power transfer in the circuit shown below. This is the given circuit. So here we have to find the value of RL such that the maximum power should be transformed to RL. That's why it is shown as variable that RL value is supposed to calculate. So here we can see that this circuit consists of dependent source and independent source. So to find the value of RL, first we have to bring this circuit into Thevenin's equivalent circuit. So to bring it into Thevenin's equivalent circuit, we must find three parameters, as this circuit consists of dependent source and independent source. We have to find VTH, that is Thevenin's voltage. We have to find short circuit current ISC. Then we must find RTH, that is nothing but Thevenin's resistance. Once we calculate the Thevenin's resistance, then we can easily calculate RL. So first let me calculate VTH. So VTH is nothing but Thevenin's voltage that can be calculated by removing this RL. We have to make this RL open. Let me redraw the circuit. So here there was a RL, I have removed it. Now we have to find the voltage between these 2 points, that is nothing but VTH. So here this VTH can be calculated either by applying node analysis or by applying loop analysis. Now let me simplify this using loop analysis. So here I will assume that let current through this loop is say X, and anyhow current through this loop is 0.5 I1. The same current will flow through 20 ohm resistor. So let me simplify this. I'll apply KVL to this loop. I can write 50 is equal to we have 40x plus the current will flow like this. Then voltage across this will be 20. We have current X and 0.5 I1, both are in same direction, that is X plus 0.5 I1. So further I can simplify this as 50 is equal to, here we have 40x plus 20x plus 20 into 0.5 is 10 I1, or I can write 50 is equal to, here we can observe that current X is flowing in anti-clockwise direction, current I1 is flowing in clockwise direction. So I can write I1 is nothing but minus X. So wherever there is a X, I will replace it with I1. So equal to, here we have 60x plus 10 I1, or I can write 50 is equal to 60 into X is nothing but minus I1 plus 10 I1, or 50 is equal to, here we have minus 60 I1 plus 10 I1, that is 50 is equal to minus 50 I1, therefore I1 is equal to minus 1 ampere. So we found the current I1, that is minus 1 amp. So now here we can observe that voltage across these two terminal is nothing but voltage between voltage across 40 ohm resistor plus 50 is nothing but VTH, or VTH is also equal to voltage across 20 ohm resistor. So let me find. So here I can write VTH is nothing but voltage across 40 ohm resistor is 40 into I1 plus 50, or I can write VTH is equal to 40 into I1 is minus 1 plus 50, therefore VTH is equal to minus 40 plus 50, or VTH is equal to 10 volts. So we found the value of VTH, that is 10 volts. Now let's calculate ISC, that is short circuit current. So here we found the first parameter VTH. Now we have to calculate ISC. So to calculate ISC, we have to short these two terminal. Then we have to assume that current through that terminal is ISC, that we are supposed to calculate. So now to calculate ISC, we have to remove this RL and we have to short this one. So current through that shorted path is known as ISC. So let me remove this RL and short this. So the circuit looks like this. So there was RL, I have removed it. Now I have shorted. Now current through this is nothing but ISC. Here let me calculate ISC using node analysis. So this is the node here. If I consider this node voltage as V, then definitely V will be equal to 0, because this node is directly connected to the reference node. Here voltage at this node will be 0, so V will be equal to 0. So now let me apply KCL to this node. This is incoming current, I1 is outgoing, ISC is outgoing. As this path is shorted, no current flows in 20 ohm resistor. So I can write 0.5 I1 is equal to ISC plus I1, or I can write 0.5 I1 minus I1 is equal to ISC, that is ISC is equal to minus 0.5 I1, or I can write, so here I can see that, we can see that I1 is equal to, voltage at this node is 0, 0 minus 50 divided by 40, that is nothing but minus 50 by 40, that is I1 equal to minus 1.25 amp. Therefore I can write IS is equal to minus 0.5 into minus 1.25. So simplifying this, will get IS is equal to 0.625 amps. So this is short circuit current ISC. Therefore we can find RTH. RTH is equal to VTH by ISC. So VTH is 10 volts, ISC is 0.625. Therefore RTH will be equal to 16 ohm. Now let me draw the Thevenin's equivalent circuit. So Thevenin's equivalent circuit consists of VTH in series with RTH. This is RTH, its value is 16, VTH is 10 volt, and here we supposed to connect RL. So this is RL which is supposed to be calculated. So this RL should be connected there. This is RL. We know that in the maximum power will be delivered only when this RL is equal to RTH. Therefore RL must be equal to 16 ohm. So therefore if RL is equal to 16 ohms, then maximum current will flow. Therefore RL must be 16 ohm. So thus we calculated the RL value which is 16 ohm. Now let's find the maximum power transfer to the load. So let me calculate current in the circuit, that is I. So here I can see that I is equal to voltage divided by resistor, that is 10 divided by 16 plus 16. These two are in series, that is 10 divided by 32, which gives 0.3125. So therefore we can find maximum power Pmax is equal to I square into 16, that is I square into 16, that is 0.3125 square into 16. Let me calculate this. So it gives 1.5625 watts. This is the required result. Thank you for watching.